is that some of the things that we have learned, some of the things that we have accomplished over the year gets done every single day, like add, subtract, multiply, and divide. And now that we know positive and negative numbers, I can absolutely positively give you the more complicated ones. Oh, I don't want to do that yet. Let me do this first. There we go. All right. So one of the first things we learned was order of operations. All right. Bo, tell me about order of operations. Absolutely not. What's the saying we have for order of operations? Thank you, Bo. All right, PEMDAS. We have done, or GEMDAS we'll use next year. PEMDAS, every one of those letters stands for something, Bo. What do they stand for? E? Exponents. And division. They go together. All right, the two that you got to be careful with are the multiplication, division, adding, subtracting. They go together. That means you do all multiplication and division, but you do them in a specific order. Malachi, you must always go left to right. Very good. All right. Remember, I told you many times this year, I said I didn't pay any attention in 7th and 8th grade. And I literally thought you were supposed to do all the multiplication first and then the division. And some of you that are only paying a little bit of attention, probably that's what you just heard. No, you don't do the multiplication first, then the division. Once you get to the step where there's nothing but multiplication division, you do all the multiplication division left to right. Once that's done, then you move on to adding, subtracting, you do that left to right. All right, so let's follow the letters. The first letter here is number 1. First letter here is? First letter here is? P. P. Do we have any parentheses? Yeah. We got tons of parentheses. Some of the parentheses only have one number inside. Remember, when there's negatives involved, we tend to put them inside parentheses. But there's one set of parentheses there that has 2 numbers in. Let's do those first. 1 minus 5. I heard 4 and -4. Which one? -4. Oh, very nice. Different signs. Subtract, big minus small, more negatives and positives. So I'm going to rewrite what I have. -6. I have to do this on the computer. I forgot. E-learners. They're going to see absolutely nothing if I don't do it on the computer. All right, grab your pencils. Rewrite the equation. Rewrite the equation. So we have -6 with a set of parentheses. Minus, I haven't done anything with the 5, so it's 5. But you guys all told me that 1 minus 5 is -4. Now this one is scary because look at all those parentheses. It can become confusing. Do we have any more parentheses left that there's something to do inside? Do we?
No.
Which one? Do we have any exponents?
No.
We move on to multiplication and division. Any multiplication or division?
Yes.
What are we multiplying?
5 times -4.
What is 5 times -4? So I write -6. Hey, did we do anything with this minus sign right here? It's still there. And you told me that 5 times -4 is? Do you see the 2 negative signs? Keegan, grab your pencil. You're supposed to be writing. You see the 2 negative signs? What do?
You subtract.
We turn them into one positive. So we have -6 plus 20. Same or different signs?
Different.
So that means the final answer is positive or -14? Because there's more. Look how many positives we have, 20 of them. So more positive. So the final answer is 14. There is a, well, I would say I would absolutely not do this one in my head. There's what, 3 steps there? That's too many. 2 steps, I could probably say you probably could handle that, but 3 steps, you're going to make a silly mistake if you try to do 3 steps in your head. Oh, there's, going back to Caden, there's Einstein could do, 3 steps in her head, but we're not Einstein. Let's write some of these out.
Mr. Schroeder, I have a question.
Yes.
Do you want me to take a picture of this and send it to you? Or do you just want me
to? You missed the big long Einstein speech before I hit the record button, and I reminded everyone that there is no homework today. This is just classwork. All right, so there is our order of operation. We shall do one more. Malachi, pick one of the first, is it 6? Yeah, first 6 ones, pick one. Let's do number 2. Do we have any parentheses?
Yes.
Okay, parentheses, what does it say? It says 5 minus 1. The 2 minuses would turn into?
A positive.
So 5 plus 1 is?
6.
So I write a 6. I'm going to put it in parentheses. And then I have this 8 divided by 2. It's also in parentheses.
And that's 4.
And this is why some people who can do 2 steps in their head can see what this turns into. When you only have multiplication and division, oh, by the way, we still have something inside parentheses, 8 divided by 2, which you said was what?
4.
And times 6 is? Very good. Questions on order of operations? Why did I write 24? That's wrong. The answer is 24, but 4 times 6 is 24. There we go. Now it's correct. Technically, there should be equal signs here because you're saying each time that the previous one equals the next one. Okay, questions? All right, the second category of stuff we learned this year is questions 7 through 11. Guess what that means? Somebody. It is an algebra problem, and it is asking us to do what? Why do I have the wrong question here? 7 is not that. This looks like, oh, I have the wrong thing in my hand. Duh. It's like, that's the 8th grade one. Okay, here we go. Yes, it is algebra. It is one-step equations. Jaden, where's the x? Where is the x? Same verbiage I've always used. Where is the x? Let her talk. This is how I figure out who can recall this and who can't. What's attached to it? What's attached to it? How is 17 attached? How do we get rid of division? Now, notice how it's written, right? She just said we got to multiply both sides by 17. Well, I can put a times 17 here. It's really hard to fit in over this side, so you just be careful or rewrite, either one. Grab your pencils, do this. No calculators. We just need to do it by, it's 2 numbers being multiplied. It's not that hard. What happens to the 17s on the left?
It turns into a 1.
Right? It turns into 1. 1 times x is x. Now, scratch work. 17 times 9. Gavin, 9 times 7. I write a 3, carry your 6. 9 times 1. Plus 6. And so, like I said, before you grab your calculator, it's not that bad. 153. 153. There you go. Done. Agreed. And then 9 times 1 is plus 6, 15. What? Well, that's just sloppy handwriting for me. It's a 5. All right. All right. Abby, pick one. 7 through 12. Which one? 9. We have negatives. Be careful with negatives. All right. Where's the variable?
It's on the right side.
Right side. Elijah, put your mask on. What's attached to K? Okay, Lily,
-7.
how is the -7 attached to K? How do we get rid of multiplication? Very good. We're going to divide both sides by, what number are we trying to get rid of? By -7. We're always going to either multiply or divide by the number we're trying to get rid of. I'm trying to get rid of that -7. The kid that makes a mistake on this one is going to do what? How are they going to get rid of that -7?
They're going to do a +7.
They're going to do a +7 because they're not thinking, how is it attached to K? What's a negative divided by a negative? We just had this.
A
So
positive.
divided by 7.
5.
So we get is equal K, and we're done. Yay for us. We're smart. Look
Hey,
at us.
Mr. Chartier, I have a question.
Yes.
Do you want me to wear my mask?
Yes. That's a joke. All right.
Huh?
All right. The next section are questions 13 through 18. It is still algebra, but this time it says write as a verbal expression. What does that mean? It means write what you see with words.
Ew.
I need words. Well, we have the $20 word or we have regular words. Which one you want?
$20.
What's the $20 word for division?
Quotient.
So it's quotient of n and 6. That one's done. Hey, well, remember, since it doesn't specifically say what words to use, you have a lot of choices. I mean, I would not mark that wrong, but I would prefer if you used more math vocabulary. Okay, Ace, number 14.
N plus 7.
Say it again a different way. Because I want to see if you can do it more than one ways.
7 added to n.
Okay, one more way.
N added to 7.
One more way. What's the $20 word for addition? Keep going.
Grouping.
All right, he just said it 4 different ways. 4 different ways. There's lots of ways of doing this. All right. If there's one that will cause you problems, it's this one. It's this one. Pierce, can you do this one? Do it. We're using words. I want this in words. Subtraction is the one that causes problems. No, sit. There's one way. Josh, you got another way? He said the difference of 25 and 8. That's using the $20 word. Subtraction will cause you problems. Go. Okay. Give me another way, Lily. No, that's the other way around. The one that causes everyone problems, I bet it's how they answer it in the back. They're going to start with the 8. What are they going to say? They're not going to say that because that's wrong. It's not 8 minus 25. It's 25 minus 8. They're going to start with the 8, and what are they going to say?
8 less than 25.
They're going to say the word fewer. I bet you, or less than, either one, they're going to say 8 fewer than 25. Guess what every kid in America is going to write when they say that? They're going to write 8 minus 25 and write it backwards. 8 fewer means take away 8. 8 less than, they say less than, yeah, 8 less than. So either 8 fewer or 8 less than. This is, I don't know why, but this is typically the way it's written. I like the word difference and it's hard to mess it up. But most math books, most math tests will use the word fewer or less than. All right. Moving on to 19. What are we doing here? Anyone that misses 19 does not belong in this class. What's the answer?
0.100.
It's 0.
Yeah.
All right. So instead of that, how about number 20? When you are adding and subtracting decimals, you have to follow one and only one rule. What's the rule?
My calculator knows.
Line up
You
the
have
decimal place.
Decimals. It's not multiplication or division. Multiplication, it doesn't matter where you put the decimal. But for adding, subtracting, you must line up the decimal places. Grab your pencils. The first number always goes on top. Grab your pencils. The second number goes on the bottom, but you must line up the decimal places. If you don't line up the decimal places, you will get this wrong. Draw a line, we can go to subtracting. It's the same for adding, subtracting. You must line up the decimal places. I can't take 9 from 2, so I borrow 1 from the 5. 5 becomes a 4, and the 2 becomes a 12. Now I can subtract 9 from 12. 9 from 12 leaves 3. Bring down my decimal place. And 4 minus 2 is 2, so we get 2.3. You must line up your decimal place. Yes. Hurry up. Well, when you take these tests, do you ever have to show your work? The answer is, well, on a test like CMAS, the answer is no, because your work is not graded. The final answer is graded. However, they give partial credit like I do when there is work shown. Okay. Yeah. What for? Go. What? Okay. All right. Let's go to multiplication. Multiplication. Malachi, what's the rule for multiplying with decimals? Absolutely not. Remember, 2 times 3 is the same as 3 times 2. It doesn't matter how you multiply them. Do you have to line the decimal places up? Yes or no? I did give you a recommendation to make it the easiest. And I said, does anybody remember the easiest way to stack them? Which one do you always put on top if you want
The
to do it
bigger
easy?
one.
Not the biggest one necessarily,
The
like
higher number.
But
the
yeah,
one
that's
that
what I
has the most digits.
but
Both
they,
of these have 2 digits, so it doesn't make a difference. We're not going to say the biggest number, like 10 is bigger than 9, but you're going to put the one with the most digits. And it just saves, because of the multiplication algorithm, just saves you work. So on this particular one, it doesn't matter how you stack them. Whether I put 4.3 on the top or I put 9.7, they both have 2 digits. So I can put either one. Grab your pencils. Let's do this. 9.7. Draw a line. Move your pencils. A couple of you are just staring. 7 times 3. I don't worry about the decimal place at all. I ignore the decimal place until the final answer. 7 times 4 plus 2.
21.
You said 21.
Those are-
All right, let's stop the joking, please. Okay, it's hard to tell in this class whether it's a joke or you absolutely are clueless. We bring down a 0. If it was the second number, we bring down 2 zeros. If it was the third number, so forth and so on. 9 times 3.
27.
Now, where do I put that other 2? Boy, can this get messy. On top of the other 2. I mean, it can get really messy. 9 times 4.
36,
Plus 2.
38,
We draw our line. Now we add from right to left. 1, 7, 3 plus 8.
11.
Carry your 1, 1 plus 3.
4.
Now we mess with the decimal. We count how many decimal places we have. 1, 2. So we move it over 2 from the right, and we get our final answer. What's 4 times 9? 4 times
30, 36.
And I got 41 as an answer, so it is a reasonable answer. If you're going to make a mistake, it's usually with your decimal place. All right, the one that no one likes is, let's do a division 1. All right, let's do 27. 27 division. 27 division. What? It's what? It is not 2. It is not negative 2. What's a positive divided by a positive?
A positive.
So how could it be negative?
Magic.
And it's not 2. All right. So for those of you that forgot, when it's written like this, what number, remember the doghouse or whatever it's called. I have no idea why they get a doghouse out of this. It doesn't look like a doghouse
Tree.
to me.
The fallen
All right,
tree.
what
thing.
goes on the inside? The first number or the second number?
Those
The first number goes on the, the second number goes on the outside. I was confused there for a second. And the first number goes on the inside. The only good thing about being in 7th grade is this is the last year that you see these symbols. From henceforth, I mean, you're not taking the CMAS test. From henceforth, you're not going to see the division symbol next year in 8th grade. It's going to be a fraction bar. So then you just got to remember, as you chop the fraction down, if it's A over B, the A falls on the inside, the B stays on the outside. Okay. All right. Now there are steps involved in long division with decimals. You are only allowed to divide with whole numbers. In other words, I got to change this 8.2 to a whole number. I don't have to mess with the 4 point, like I'm not actually looking at 4.1. I'm looking at the 8.2. Whatever I do to the 8.2, I will do to the 4.1. But I don't care how many decimal places are in 4.1. I only care about how many decimal places are in 8.2. How many decimal places?
1.
How many decimal places?
1.
Where do you see 2? How many decimal places and then divisor, the first number? So we only need to move it one place. Whatever we do to the divisor, we have to do to the dividend, the number on the inside. If you move the divisor once, I don't care if there's none or there's 43 decimal places on the dividend. You have to move it one place. We move it one place, and if you ever had me as a math teacher, I always recommend to immediately, so you don't screw this up. Now what do we do immediately? We move it straight to the top. That way it's sitting there exactly where it needs to go from now on. Now comes the hard part. The thing that 7th graders who still struggle at long division is, how do I figure out what numbers to put? Here's my explanation of that. I'm only looking at this number. I'm going to make it a friendly number. I don't like 82, but I certainly do like 80, 80. You see what I'm doing? Now, this is a guess and check thing, absolutely positively, but I'm going to make a number that I can deal with in my head, 80. I can't count by 82s. I can count by 80s, 80, 160, 240. And you need to be able to count by that number. So I'm going to consider that this number is 80. It might get me to the wrong answer. I'll have to backtrack and fix it, but I can at least make a good guess at what it should be, 80. Does 80 go into 4? Does 80 go into 41? Okay.
No.
Therefore, I need to add a 0. Now the number is 410. Does 80 go into 410? It does. How many times? Well, my guess is 5. Am I guaranteed that that's right? No way is it guaranteed that that's the right answer. But it's a guess and it's close. If you make a good guess, you're only going to be off by 1 if you're off. You're either going to be guessing too small or too big. So we're going to guess 5 and we're going to see if the math works. 5 times 2, 0 carrier 1. 5 times 8. What? 40 plus 1 is 41, and look at the magic there. For those of you that did nothing and watched me do this, shame on you. About half of you, I saw pencils moving. The other half, you're just sitting there. Remember the speech that we started with.
I'm
Right?
gonna hear the
You
speech.
have to have some individual motivation. You aren't going to get smarter or better at this by watching, only by doing. Some of you right now know, I still don't know how to do this, and you still are doing nothing about it. I haven't seen you for tutoring. You've never personally told me, I don't know how to do long division. Please help me. You're in 7th grade. We no longer teach this ever again, ever. You're not going to, well, they'll fix me in 8th grade. No, they won't. If you don't know how to do long division in 7th grade, we're done. Doesn't get taught ever again. You walk in the 8th grade classroom, yeah, do this long division. You're going to be doing long division between now and whenever you graduate, high school, college, whatever. You are expected to be able to do this by hand. If this is still a problem, you need to seek help. Help comes in many different flavors, help from your family, help from your math teacher, through tutoring, not through classwork. There's no more classes on long division. All right, long division though is, I think for everyone, the more challenging thing. The next thing that we did, or decimal long division, not just general long division. The next thing we did was rounding. Some of you still have issues with rounding. All right, Noah, 31. Tell us the rules for rounding. Just the general. What do we do to round? Step number 1, what do you do? Look at the 2. How do we round? Once again, Rounding is not even taught in 7th grade. It's a 4th and 5th and 6th grade thing. 7th grade, you're expected to know how to round. If you've made it to 7th grade and you don't know how to round, like you can't teach, I mean, if you don't know how to teach this to a 2nd grader, you don't know how to round. Some of these things that you identify that, yeah, I'm weak at this, you need to start asking for help. Caden, how do we round? Which digit? So I look at the digit that's underlined. Now, will they always be underlined?
No.
Typically, it'll say round to the nearest thousandth. So they've already underlined the digit they want you to round to. So step number 1 is you underline the digit that you're rounding to. It's already been done for you. I don't want to do that. That's not the procedure for rounding. What's the next step after you identify what you're rounding to? Does anyone in this class know how to round? Go
Yes.
for it. I look to the right. See the number that's underlined? I immediately look to the right, not to the left, not to the number that's underlined, but the number to the right. Go ahead, keep talking. If the number that we're looking at, the number to the right, is 5 or more, I'm going to go back to the one that's underlined and increase it by 1. What happens if it's not? I leave it. I don't turn it into a 0. Excuse me. I just leave it alone. So is 3 5 or more?
No.
It's not. So I basically get rid of this digit, and there's your answer. That's it.
Wow.
Hey, you guys are really worrying me that no one except for one student, good job.
I know how to round.
Rounding is actually really easy.
It is really easy. It's like, give me 20 of these. I'll get them all right. The ones that you won't make a mistake are the ones that have 9s in them. For instance, if I give you 4.99961, and I ask you to round to the nearest thousandths place. So where's the thousandths place?
The last 9.
It's the last 9. Okay, so that's the one we underlined. Keep going.
And then you look towards the 6, and if it's 5 or more, you round that one to 1.
What?
And you round 9 more, right?
You're losing me.
Okay.
All right,
I
Pierce, talk.
Okay, so you look at the
5 or above, because 5 would count as being 5 or above.
and then but that 9 will change to
9 will increase by 1, which makes it,
10, but which will make
well, I got to
10,
carry a 1, which would make that 9,
10,
which would make that 9,
10, and then the 4.
and you got to, don't forget your decimal. Oh, it turns into 5. That number rounds to 5. Even though I rounded to the nearest thousandths place, and actually the final answer is a big honking 5, and that's it. All right, moving on. 35 through 38. Who can teach it to the class? 35 through 38. Go, Ace. By its angles, give me the 3 types of triangles by angle measurement. Go. Acute,
and right.
obtuse, and right. By angles, there's only 3: acute, right, or obtuse. If it's a right a triangle, you will always see.
90 degrees.
Is there a 9-degree angle here?
No.
So it's either acute or obtuse.
It's obtuse because is higher than.
One of these angles is 100 degrees, therefore it is obtuse. Very good. Okay. Class, what's 36 by angles?
It's a right
What's
angle.
37?
Acute.
We also might call this one equiangular because all the angles are the same.
Ew.
Well, that was
Right.
pretty. All right, by its sides, who's got, there's 4 of them.
Scaling.
Go.
Scaling.
There is scaling, no sides are the same. What's the next one?
Equilateral.
Equilateral, all the sides are the same.
What's the last one? It's got 2 sides.
I said 4, I meant 3. Isosceles.
I thought
Okay.
it meant 4.
So how do we know, Malachi, that this one, he says it's scaling. How do we know this one's scaling? All the sides are different. One tick mark would go with another triangle that had one tick mark, right? Since all three sides are different, this one's scaling. Class, this one is?
Scaling.
Oh, that's easy. This one is?
Scaling.
Are they all scaling?
Equilateral.
All right. Questions 43 through, what are we on? 43 through 46. Who can teach this to the class? Oh, you got it? Okay. All right. We are on Gavin. Teach it. How big is angle B? Well, I don't know. How am I supposed to figure this out? Shh, let me teach.
So what you need to do is with 83
Why would I do that?
because to figure out what that one is, all triangles with all of their angles added up, you get 100.
There's the key idea. If you add up, go. If you add up all the sides of a triangle, right? And by the way, you don't have to ask permission for that, Caden. All the sides of the, or I'm sorry, angles, all the what? It's okay. He's got a bloody nose. All the angles added up together is 180. So if I know two of them, what's the process?
You just add those two up, and then whenever you get that number, you subtract it.
I know what you meant. You just said it badly. We add up the two, and then we take that sum and there, you said it perfect. Okay. So all we got to do is add up 57 and 86, add those two together, subtract from 180. Anybody got the answer?
Yes.
What is?
37.
37 degrees. Therefore, what kind of triangle is it? It is an acute triangle. All the angles are acute.
If only you had 4 more degrees.
Well, you guys are doing pretty good. There's only been a couple things that we haven't been able to figure out. All right. We haven't done this in a while. Quadrilaterals. Lily, give me a name of a quadrilateral that you remember. Give me a name of a quadrilateral. A rhombus. What do we know about a rhombus or rhombi? Rhombus has 4 sides, and all the sides
Are slanted.
that's parallelogram are equal. So if it is a rhombus, all the sides are equal. Hey, are these tick marks or are these triangles?
Triangles.
What do the triangles mean?
Like,
It
it's
is-
the same as the.
We had this in class a while ago.
It's the same as the tick marks. It shows it.
It's not tick marks.
It shows it.
It doesn't show equal
No,
sides.
parallel.
Parallel. Triangles, these little black triangles right here mean those. One with 2 is parallel to the one with 2. The one with 1. Hey, so this says opposite sides are parallel. That makes this a
Parallelogram.
parallelogram. That makes 48 not a parallelogram. This makes 48 what? Rhombus, a trapezoid. That makes 49 a opposite sides are parallel and all 4 sides are equal. That makes it a rhombus. Is that the last one? Hey, I got nothing. All rhombi are parallelogram. They said the most specific name for it.
No,
What's 50?
square. A very
Clearly not a square.
A quadrilateral.
It's just a quadrilateral. There's nothing you can say about it other than it's got 4 sides. Okay, done with that.
Rectangle.
51 is a rectangle and 52 is a square. Look at that.
I know.
All right. We haven't done this for a while. Who remembers the formula for circumference? Go, Pierce.
I do. Isn't
E
it
for
like
circumference is equal to,
pi r square?
let Pierce talk.
Oh, sorry, my bad. I thought you said my name.
Nope, that's not it. Nick, you got it? No, that's area. That's area. No, radius times pi is not it. Malachi? Diameter times pi. So we would say pi d. Now, there was another formula that had radius in it. How many radii are in one diameter?
2.
So we could say the one that I don't like, 2 pi r. Notice that's not pi r squared, that's 2 pi r. So that would be our second formula for circumference. All right. What do we got left? What do we got left? What do we got left? Circles, and is that it? That is it. So the last formula is the one that you all tried to tell me was the circumference formula, which is the area formula. What's the formula for area, Jaden? A for area. Area is equal to, for circles, that's circumference. What's the formula? Everyone said that. I said, no, that's area. That's, I asked for circumference, you give me area. Now I'm asking for area, you're giving me circumference.
You want 2 pi r, right?
Pi r squared. Remember, when you square something, you get a bigger number than when you multiply by 2. All right, we got 7 minutes remaining. Pick and choose. You must work in silence from now until the bell rings. Pick and choose anything you want to work on the sheet of paper in front of you. Do not throw this away. You will need it for student advisement. It'll be the last thing. If you have nothing to do in student advisement, Mrs. Boyd and myself will say, get out your math sheet and do math.
We're not in your student advisement.
I have a question.
Oh, that's right. This is Coleman. Yes.
What's circumference again? I couldn't hear
Circumference
it.
is pi d. Pi times the diameter, or 2 pi r. What?
Oh, okay.
Put your mask on.
Sorry, I didn't get the. I did not get the. What's the $20 worth of multiplication?
Which one? C for circumference is equal to pi times the diameter, or you don't like that, 2 pi r. Because remember, 2 radii would make 1 diameter. Yeah. Product. And remember, multiplication is commutative, so you can say it either way. The product of 2 times 3, or 2 and 3, or 3 and 2, you get the same answer. Addition is commutative, and multiplication is commutative. Subtraction and division are not commutative, so order absolutely positively matters. 4 divided by 2 is not the same as 2 divided by 4. Noah, you're doing nothing. Grab your pencil, get to work. If I don't think you're working, you'll be doing lunch detention with me in my room,
That sounds like fun.
doing math worksheets.
Never mind.
And then I'm coming around to grab your homework from last night. Homework. Okay? You didn't turn in homework yesterday. Yes.
I made a very executive decision with my homework. I decided I wanted a break from it, so I decided not to do it.
Your future boss will make that executive decision and fire you.
You know
You
what I'm gonna
can't
say?
fire us.
Good luck.
You
You know. What's up? And whoever I just sent comes back. Who did I just send? Homework? Don't forget, homework. Don't.
What's better, like
Homework. I did homework from you yesterday. Homework? Are you arguing with me? What happens? What? Okay, cool. So you're lying. Ace, homework? You were like a broken record, my man.
Broken record.
You know,
Game is
that's more than what you have in the past. Is it? You at least attempted it.
I don't take Latin anymore. I take English.
You're in 7th grade. You go to our school. Guess how many more years in Latin you have?
I've been doing it since I was 5.
Oh, nice.
I think I know.
I don't believe that at all. What is danger?
How do you say water in Latin?
Water.
Aqua. That's in Spanish.
How do you say blood in Latin?
No, Nico.
What?
No, it's Necromatorius.
Exactly.
No, saying that to Viviana, like,
I know.
Kevin, what is danger?
How do you say ghost in Latin?
You don't need to know how to say that.
Spooky. No, sure about that, Kevin?
I'm giving you all the words that I know in Latin.
Here, do you wanna know? Do you wanna know? I know how to say. You wanna know what else I know how to say? Elephant, not off the top of my head though. And funny.
How do you say water horse in Latin?
Aqua horsey.
No, it's like.
You ready?
Hippopotamus. What's that?
It's actually Greek, but
Can I-
water horse.
I don't.
Hippopotamus.
Hippopotamus means is water horse.
No, it's not a horse.
Hippopotamus.
Duh.
It's a water, because it can easily eat you. Like, it almost like.
Agreed, but that's how
It's a
it's Greek though. It's not
It's a
Latin.
Mr. 38, you know what I know how to say? Under the dog.
Under the dog.
Yes.
Say under the dog line.
Ubi canine.
When the bell rings. All right, Vea and anyone else that's online, we're gonna stop it right here.
All right.
We-
Bye,
This
guys.
process for 2 more days. 2 more days.
See you guys when I'm